Hello all. Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering. Now, today's topic is Design and Selection of Grippers. In the previous class, we have seen what is a gripper and how the gripper will be working. What are the different types of grippers used in robotics. Now we'll see in detail. Some grippers are there. We'll see what is an end effector first. So end effector is a device that attaches to the wrist of the robotic arm that enables the general purpose robot to perform a specific task. Any end effector, the device which is connected to the end point of the robot is called as end effector. This end effector mainly have two functions, like it can act as a gripper or it can act as a tool. There are two types of end effectors. So, if I choose a gripper to be attached to the robot, you can see in this first picture, there is a mechanical gripper attached to the robotic arm. This mechanical gripper is used to hold the objects, and this can be used to move the objects from one place to another place. So, different types of grippers are there. We have seen 4 different types of grippers in the previous class, and now we are going to see the remaining 2 types of grippers in this class. And second kind of end effectors are tools. We can connect multiple tools to the robotic endpoint. They are like welding tool, painting tool, machining tools, etc. So we have seen lot of grippers are there. First kind is mechanical gripper. Second one is magnetic gripper. Third one is vacuum gripper. And fourth one is inflatable bladder type gripper. Inflatable. So these are some of the examples of grippers. Now in this lecture, we are going to see another 2 types of grippers. They are hooks and scoops. Now we'll see what is an hook and how it functions. You can see that a hook may be all that is needed to lift a part, especially if precise positioning is not required and if it is not only to be dipped into the liquid. So where do we use this kind of hooks? So this is a end effector. It can be connected to the end point of the robot where it can be used to lift loads. So the loads might be different, and loads depending on the application, multiple loads can be lifted using any of these kind of hooks. There are 3 design hooks are there here. First one is open hook, second one is locked hook, and third one is this is U hook, which has very high strength capability compared to the other 2 hooks. Okay. Now, where do we use hooks in robots? In robots, we use hooks for lifting the mechanical parts when they are used to be dipped in a paint, or if they are dipping in a oil bath. Okay, when we are doing machining process, the mechanical elements which are made up of metals, they are processed in such a way that to increase the life and the strength of the metal parts, we will dip them in different kind of solutions. Like we will call them as oil bath. So in order to dip the body parts in the oil, we will use these hooks. So these hooks are connected to the end point of the arm, and hooks are used to load and unload parts hanging from the overhead conveyors. So hooks are also used for removing the parts from the overhead conveyors. Overhead conveyors are the big conveyors which are used in the industries to carry loads inside the building. I mean inside the industry infrastructure. Okay. Now these hooks are used for removing or loading the objects to the overhead conveyors. Okay. Because these are small hooks which are connected to the robot. These are used to carry very small amount of loads as we take. The parts to be handled by a hook must have some sort of handle, eye bolt or ring to enable the hook to hold it. So if we want to use a this hook, in order to lift a body, lift a mechanical part, we should have some kind of handle. Like if I want to lift a box, this box should have a handle in order to, so this box should have a handle or a eye bolt or a ring should be attached to the body, so that we can fix this hook into the handle or a eye bolt, and we can easily lift the body. Okay, so there are different types of hooks are there. First kind is, this is a normal type of hook where we can lift normal loads, and loading and unloading from this hook is very easy, and this is used for very small length applications. When we want to move the objects between a small displacement, we can use this type of hooks. And because loading and unloading is very easy, there is no locking mechanism here. So that is why this first kind of hooks are used for small displacements and moving from object from one place to another. And second kind of hook is, this is locked hook, where we can attach a lock so that the object does not come out of the hook when it is being transported. Okay, so this hook is connected with the help of a spring, where it can be, after loading, the lock can be locked, and removing the, or there is no misplacement, there is no accidental removing of the object from the hook is possible. It is not at all possible. Okay, so this hook is locked hook. Okay, so this is used when the objects are to be moved from very far distance. Like if I want to move the object from one end of the building to another end of the building, I can use this kind of hook. Okay, with the help of this hook, I can move the objects to a very far distance, because they are locked and the object will not be moved out easily. And the third kind is, this is a special U hook, where it can carry more load when compared to first and second kind. So the third hook is, it is designed in such a way that it can carry more load. Okay, suppose if the first hook carries about 10 kilograms and the second one also carries about the same 12 kilograms, but this third hook, it can carry up to a load of 20 kilograms. Because of its designed curved design, it can carry more load. Here we can see the curvature of this hook is very large. In the first hook, the curvature is very large. In the third hook, the curvature is very small. It is almost bent towards the body of the hook. So this will have, or this can carry more tension. Whenever a load is applied on this body, on this hook, a lot of tension will be created inside the hook. And because of the tension, the hooks may fail. Hooks can easily bend out. Okay. So that is why the shape of this third kind of hook is designed in such a way that because of the heavy loading capability, it does not bend over. It does not bend outside the its design. Okay. So these are some of the grippers. This is hooks are used as grippers in robotics. Now we'll go to the next slide. So this is a scoop. We all know these are the scoops which is used to lift some any particles, like loose particles are there, like sand or some kind of material will be there that can be easily scooped with the help of this scoop. So the scoop is also attached to the robotic arm, where it can be used to move particles or aggregate particles from one place to another place. So this must be used for very small displacements. When we want to move the distance, when we want to move the objects between a small distance or a small path, then this is very useful. Okay, using this scoop for a large displacement is not at all recommended. And see here, a scoop or ladle is commonly used to scoop up molten metal and transfer it to the mold. So generally, the scoop is used for lifting the molten metal from the crucible or the furnace, and this metal is transferred to the mold cavity. We all know in manufacturing processes, we deal the process called casting. This is the first basic process which we learn in manufacturing practice or production technology. So in casting, if we want to automate the casting process, we can automate like filling the cope and drag. We will fill these two boxes. So cope and drag are the two boxes which are used for casting process. These two boxes should be filled with sand. So if I want to automate this process, in conventional method, I will pour the sand into the box and I will ram with hand in the conventionally. If I want to automate that process, I can use a robot for that. And after ramming, the casted, whatever the mold is there, the mold will be created in the sand particles. Mold is nothing but the cavity which is produced inside the sand for getting required object of metal. Okay. So that is different subject. So cope and drag boxes are filled with sand, and into the sand we will have a cavity. In this cavity we have to pour the molten metal. The metal in the liquid state has to be poured into the cope and drag box into the cavity. So for that process, I can use the scoop which is attached to the robot. So I am automating this process. In conventional casting, human being has to hold the body, hold the crucible from the furnace, and he has to go to the casting box, and then he has to carefully pour the molten metal into the casting. But here I can use a scoop which is attached to the robot, and this robot can collect the molten metal from the furnace, and it can move from that furnace to sand casting cavity, and in the cavity it will carefully pour the molten metal. Now this process is very easy, and because there is a lot of temperature involved in this process, the robots should be designed in such a way that they can be easily carry out the work at high temperatures. Because casting requires a lot of temperature. If we take the example of iron, if I want to melt iron, I should heat the iron at about 1500 degrees centigrade. So at a 1500 degrees centigrade temperature, a human being cannot work for longer periods. That is why we are automating this process. We are using robots for collecting the molten metal from the furnace and pouring it into the cavity of the casting. Okay, now scoops are very used in this process, and as already we have discussed that scoops are used for small displacements only, from moving the molten metal from furnace to the cavity box. This is all it can do, and more than that it cannot move the object because it is working with hot metal. If the hot metal is subjected to the atmosphere, it will easily get solidified, and the solidified iron will be stuck into the scoop, so which causes the failure of the scoop. So that is why very small displacements are possible when we are using a scoop, and when we are working with molten metal. Now scoops are used for handling the materials in liquid or powder form. So this is powder. So whenever the objects or the material which we want to move from one place to another place, if they are in liquid or powder form, we can use scoops. Okay. So there are some limitations of the scoops. It is difficult to control the amount of material being handled because the scoops are open and they cannot be easily controlled. That is why there is a limitation where we cannot control the amount of material it is carrying out. Okay. In addition, spilling of the material during the handling is another problem. So there is another problem because the scoop is very open. Whenever we want to shift some materials using the open scoop, the scoop will easily make the material to fall down some of its content. Okay, so the scoops have some advantages and some disadvantages also. So these are mostly used in sand casting process. Now, these are the two types of grippers which are being used in the industry. As we have seen, these are the hooks which are connected to the end effector, and this is a scoop which is connected for carrying the molten metal or powder forms from one place to another place. Now we'll go to the next slide, where previously we have discussed all these parts. First one is mechanical gripper, and then magnetic gripper, vacuum gripper, and expandable bladder type gripper. So these are the four grippers which we were discussed in the previous class, and apart from them, another two grippers we have discussed now. Now we'll see some important considerations about gripper. When we are talking about a gripper is a mechanical device. Here we can see a gripper is a device which can hold objects. Like if the mechanical grippers are taken in, for example, they use some mechanical parts for holding the objects. Like we can see here, the blue color parts are the objects where they are held by the mechanical hands or handles. And in magnetic gripper, we can use a electromagnet or a permanent magnet, depending on the application, where it can hold the object by electromagnetic capability. And in the vacuum grippers, we will use the suction process, suction capability of the air. With the help of suction cups, we will lift objects. So this is another type of gripper. And expandable bladder type gripper. These are mostly used for water bottles or glass bottles, where they can be lifted by using a compressed air which is inflated into the rubber cap. Okay, these are the different types of grippers. So we have some considerations. So while designing a gripper, we should have some considerations before designing a gripper. So let us see what are the different considerations we should keep in mind while designing a gripper. Or the first one is part specification. When we are calculating the design, the dimensions of the gripper, we should keep in mind all these points. Part specifications should be kept in mind. First and foremost thing we should keep in mind is what is the weight of the object which should be lifted by using this gripper. Because we are always lifting objects by using different kinds of grippers. We should know what is the weight of the gripper. If the weight is more, we have to design a gripper which is having more strength. And second one, size and shape. Depending on the size and shape also, the gripper has to be modified. Suppose if I use a gripper which is made for a cylindrical object, I cannot use this for a rectangular object. We can see in the previous slide. See here, this gripper, this mechanical gripper is used to hold a cylindrical object. The objects are cylindrical or circular. So I cannot use this for a triangular object because it cannot hold properly. Okay, that is why the shape of the object is also very important while designing the gripper. Okay, see here, size and shape of the gripper, size and shape of the object is very important while designing the gripper. Tolerance on the part size. Tolerance means how much amount of pressure we can apply or how much distance we can leave on the object while holding. Okay, so that is tolerance should be calculated. That means plus or minus 0.5 mm or 0.1 mm tolerances should be kept in mind while designing the gripper. And then surface finish of the object. Why do we take the surface finish into consideration? Because surface finish also plays a major role. If the object is very smooth, then we cannot use a mechanical gripper. This we have already discussed in the previous lectures. If we want to use a gripper which can lift a very soft and very surface finished product, we have to use suction cups or vacuum gripper. Okay, we cannot use mechanical gripper because of the surface is very fine. The mechanical gripper cannot have a good grip on the part. Okay, and then last one is care for delicacy of the part. Suppose if I want to use the gripper for holding a glass item or a material which is very fragile, okay, then that also should be considered while designing the gripper so that the gripper does not break the object. If I apply more pressure by the mechanical gripper, okay, Anyway, I have to apply some pressure by using the mechanical grippers. The two fingers of the mechanical gripper should be held tightly towards the object. So the force applied by these two fingers should not be more, or they should not be more enough to break the objects. Okay. Now, second kind of a parameter what we should keep in mind while designing the considerations, designing the gripper. So, performance specifications. Coefficient of friction between the part and object. As we know, friction plays a main role when we are designing a gripper, because the friction should be more enough between the object and the gripper parts, so that the gripper will easily hold the object. Okay. So the coefficient of friction should be high. Speed and acceleration during motion. When we are moving the robot at a normal speed, the gripper should hold the object in one way. If we are moving the object with the help of a robot, if we are moving very fastly, the gripper should hold the object very tightly, so that the object may not come out of the gripper. So speed and acceleration is also considered very carefully. Accuracy and the repeatability of the robot. So depending on the accuracy, if the robot has to move the object, or if the robot is used for aligning or fixing a bolt into the hole, the robot should be carefully designed in such a way that the object is carefully inserted into the hole. Okay. So the design considerations also plays a major role here because of the accuracy and repeatability. If the robot is doing the same work for n number of times, it should not lose the accuracy. And then memory capacity of the controller. So for following all these conditions, if I write a big program, if the memory of the robot is not enough to store this program, then it is not going to be useful, because I cannot store the program which is written for the particular purpose. If the robot cannot store the program in its RAM, then there is no point of writing big code. So the program or the code of instructions should be small as possible. And then second kind of parameter we should keep in mind is source specification. What are the different sources we are using for actuating the gripper? So first one is pneumatic, air, pressure and discharge. So what is if I am using a pneumatic compressor for operating the gripper, so what is the amount of air that is to be applied on the gripper fingers? So that should be kept in mind. If I am using a electrical actuator, then the power rating and specifications of the actuators also taken into consideration. And if I am using a hydraulic actuator, the oil pressure, volume, mechanical linkage design, everything has to be taken into consideration. So keeping all these designs in mind, the design of the gripper should be done. Okay, pneumatic, electrical and hydraulic, different grippers are there. And in position specifications are holding methods. How should I hold the body? Should I hold the object horizontally? Should I hold the object vertically? Or should I hold the object inclinedly? So that is also considered. And physical difficulty. If there are any possibilities where the object cannot be held with the gripper, then that also considered, and accordingly a new gripper design should be made for holding the object with irregular shapes. Next, length of the fingers. Length of the fingers also should be designed in such a way there is no extra length of the fingers is made, because they are vastly made in the process, and the length of the fingers should be good enough. They should not be small and they should not be large for holding the objects. Okay. And the object and tool orientation. The objects which are placed in the gripper and the tool orientation also should be considered while considering the designs of gripper. Spare part specifications also should be kept in mind. Suppose I have designed something. The gripper I have designed. If the spare parts for that gripper are not available in the market, then I cannot design that, because sometime after usage, the gripper parts may eventually spoil or they may damage. So those parts has to be replaced with new parts. If my design does not have a spare part specification. That means my spare parts are not available in the market. Then I cannot change the old parts which are failed during the work process. So that is why spare part specifications also should be kept in mind. And then environmental specifications. So environmental specifications are heat and temperature of the object, humidity and moisture, dirt and safety, hazardous of chemicals used. So when I have an object which is hot, the gripper should hold the temperature, or if it is cold, the gripper has to it has to bear the temperatures, different temperatures. If the body is being used in an environment where the humidity is more, where the moisture is more, that also should be considered, because the humidity or moisture may cause damage to the mechanical parts in the gripper and they may fail the gripper to work. Okay, dirt and safety. Some places will be there where the environment will be very dirty, so that also should be kept in mind. And safety is the first thing. If the gripper is about to fail, it should not cause any failure while it is working. So the gripper parts should be designed with more factor of safety. And hazardous of chemicals used. If there are chemicals which are being transported by any gripper from one place to another place, they should not cause any harm to the robotic body. And then material specifications. So what are the material specifications? Strength and rigidity of the body, durability and fatigue factor, friction properties, factor of safety, design standards. So all these things should be kept in mind. Strength and rigidity. Suppose I designed a gripper which can hold the object at a force of 5 kilograms. If the body does not have the capability of holding a strength of 5 kilograms, the object will break easily. Because of holding with the gripper, the object is being broken. So this should not be happen. The strength is also kept in mind. Durability is also kept in mind, because we might be using the same object again and again for gripping with gripper. So the durability is also kept in mind. Friction properties, we have discussed this in the first point. Second point, the factor of safety, the friction properties, and the design standards, all these designs properties should be kept in mind while designing a mechanical or any kind of gripper which is used for holding objects. Now there are some other considerations while we select a particular type of gripper. So see here, these are the points we should keep in mind while selecting a gripper. So first one is actuation selection. So what is actuation and what is an actuator? We have seen in the previous lectures. An actuator is a device which can create linear or rotary motion. Some examples of actuators are hydraulic, pneumatic and electric motors. Hydraulic piston, pneumatic piston and electric motors. So while we are selecting a gripper, we should consider these points. Which kind of actuation we are using? Which kind of actuation is more suitable for the particular purpose? Okay. So the first one is mechanical or friction gripping methods. So this has to be taken into mind. So mechanical or friction gripping methods. What kind of gripping methods we are using for a particular object? Okay. And then pad shapes selection. What is the shape of the pad which is being placed on the mechanical gripper or any kind of gripper for holding the object? Okay. And then vacuum actuation. We know vacuum actuation is very fast and rapid. It takes very less time when when the object is held by a gripper which is actuated by a vacuum pump. The vacuum, when it is opened, compressed air will come into contact immediately. So this also should be considered. And then magnetic grasping. So while using a magnetic gripper, we should know whether the object is magnetic or not. It should have the magnetic property. If it does not have a magnetic property, there is no use of using a magnetic grasping method. And then adhesive gripping. Adhesive gripping is similar to magnetic gripping, where we will use some kind of adhesive on the surface to hold the objects. But this is very harmful, and sometimes the adhesive gripping itself will cause damage to the object. Either it can create a layer of adhesive on the object, and sometimes the adhesive is not strong enough to lift the object and it will be dropped instantly. Expandable bladder type actuator. Okay, we all know these expandable bladder type actuators are used for holding the objects like bottles and glass items. So, depending on the actuator, we have to select all these any kind of grippers: mechanical gripper, pad gripper, vacuum gripper, magnetic gripper, adhesive gripping, and expandable bladder type gripping. So, depending on the type of objects we are using, depending on the type of object we want to lift, then we can select any of these gripper for the particular purpose. And then drive selection. So we have to select a different drive for each different application. So first one is pneumatic drive system. If I use a pneumatic drive system, it uses compressed air. So compressed air requires a separate system where we have to use an air compressor. It will take an extra energy, and they are connected by pipes to the pneumatic gripper. Why, if I am using a hydraulic drive system for heavy duty operations, then different drive selection should be done. Okay, so if I use an electric drive for light duty applications, when I want to lift some very low loads, I can use electrical drives like stepper motors, etc., where I can lift the loads by using these drives. And the speed reduction of the mechanical transmission. Speed reduction of the mechanical transmission also should be carefully considered, because if I use a motor which is running at 100 rpm, I cannot use the actual speed of the motor to lift an object by using a pulley. Okay, if I use that actual speed of the motor, the object will be instantly moved up and it may cause some damage to the robot or damage to the object itself. So that is why the speed reduction has to be done while we are using motors. I cannot use the actual speed of the motor. I have to reduce the speed by using some gear mechanism. And then protection shielding. So different protections has to be applied to the robot in order to protect the robot from environment. Heat shield for sensors and actuators should be given in order to protect them. So forced cooling by air or water cooling to take away the heat. This has to be given to the robot in order to protect it from hot environments. And the selection of heat resistant materials for fingers and components of the gripper. Even though if we cover the gripper or the entire robotic body, if we cover with some kind of material or insulation, the gripper has to be in the actual environment. It cannot be covered with some kind of insulation, because they may lose their gripping mechanism or it may lose friction because of the friction material being used for the design of the gripper. So the gripper has to be in the outside environment where it has to work. So the material itself should be selected in such a way that it can bear a lot of high temperatures or cold temperatures. And then shield from hazardous chemicals. The mechanical elements of the gripper should be covered in such a way that any chemicals which are being used in the environment, they cannot cause any harm, because atmospheric oxygen is very dangerous for metal like iron. They simply get corroded. And then process selection. Depending on the process, some process points are there which has to be kept in mind while selecting a robotic gripper. Accurate processing method for fingers. So what kind of process is being used for operating the fingers? That method has to be taken into consideration. Leak prevention for pneumatic or hydraulic actuators. While we are using pneumatic or hydraulic actuators, we need some kind of mechanism where in pneumatic compressors, we will use a compressor which can store the air at a high pressure in a tank. Okay. And if we are using a hydraulic actuator, this hydraulic actuator uses a compressed oil which is stored in an oil tank. So these two things has to be carefully sealed. They should not leak into atmosphere. Okay. If there are any leaks, they may cause failure of the hydraulic or pneumatic drive. So that is why they have to kept leak proof. Okay. And then interchangeability standards for the fingers. We have already discussed that the fingers of the gripper should be designed in such a way that they can be easily interchangeable with the spare parts. So they should be close enough to the spare availability. shape compatibility processing methods for fingers. So depending on the object, we should design the shape of the fingers. And last point is ease of assembly of fingers and linkage. So when we want to replace the fingers of the gripper which are broken, the process of replacing the old fingers of the gripper should be very easy. Okay, it should not be very complex, so that a layman should be easily able to change the fingers of the gripper. So these are points which are related to design considerations and selection considerations. And before that, we have seen two types of grippers. Okay, so in this class we have seen grippers. They are hooks and scoops. And after that, we have seen what are the design considerations we have to keep in mind while designing a gripper, either it is a mechanical or magnetic gripper. And after that, we have seen selection of the gripper. What are the different points we have to keep in mind while selecting a gripper? So that's all for this lecture. We'll meet in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.